How can I use angles of elevation and depression to find the distance between objects? How can I use angles of elevation and depression to find the distance between objects? So, an angle of elevation is formed by a horizontal line and an observer's line of sight to an object. Okay, so if a person is standing here, all right, horizontal line and an observer's line of sight to an object. So the horizontal line comes out of here. There's a line parallel to the horizon, right? So it's horizontal. And now if this person is looking line of sight to an object, say they're looking at the word object. That is an angle of elevation. Right in there. That is the angle of elevation. Observer's line of sight to an object and a horizontal line. So right in there, that's an angle of elevation. An angle of depression is formed by a horizontal line and an observer's line of sight below the horizontal line. So if big tree. So if you got Chad sitting up here in this tree stand, you got the ground, and got a deer over here. It's like a 17 point. He's happy now, but he's fixing to not be happy. All right. An angle of depression is formed by a horizontal line and the observer's line of sight below the horizontal line. All right, well, here's the horizontal line coming out of the eyes. And it's parallel to the ground, all right? It's parallel to the ground. So this line creates an angle. This is the angle of depression. Right in here. Let me add a little bit of support to your tree stand there, Chad. I don't want you to fall. Now, keep in mind when you're doing these angle of depression problems, this angle of depression, you got a horizontal line out of this guy's eyes, and you got the ground. They're parallel to each other, right? That makes this line of sight a transversal. And it makes this angle right here, it makes the angle of depression and this angle alternate interior angles, and they're congruent. So you're going to be able to use that later to solve problems, find distances. Okay? Everybody good with angle of depression and angle of elevation? All right, then let's do a sample problem or an example of each in the book on page 580. Example number 1. Leah wants to see a castle and an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? All right, so you got the ground right down here. And you got Leah standing here on the ground. And she's happy because she's looking at a castle. And she's 5.5 feet tall. And I think to be real accurate, they meant to say that her eyes are 5.5 feet off the ground. Okay? Let's make her eyes. She's looking at the castle. And the castle's way over here in the distance somewhere. And they're saying the castle's 190 feet tall. Her eyes create an angle of elevation of 38 degrees. So look, from her eyes to the top of the castle. So we've got the ground and we've got a line horizontal or parallel to the ground. 38 degrees. They want to know how far she is from the castle. So this becomes a right triangle problem. And we did these all last week. It's just you're going to get the information a little bit different this week. You're going to get it in word form. Sometimes you'll get it words and a picture. Sometimes just a picture. But a lot of these are going to end up being just word problems, and you've got to draw the picture. So we're looking for this. We're looking for the distance from her to the castle. All right? What you have to be careful of here is that you don't use the 190 as your opposite side. You've got to do 190 minus 5.5. Okay? 190 minus 5.5. So this side is 184.5 feet. This side of the right triangle. That's your opposite side. And you're looking for the adjacent side. So if we go back to SOHCAHTOA from last week, in relation to this 38-degree angle, we've got opposite and we're looking for adjacent. So that becomes tan 38 equals opposite over adjacent. You're going to crisscross multiply, put the tan 38 over 1, so now you've got a proportion. So your tan 38x equals 184.5. To solve for x, you divide by whatever's in front of the variable, so we divide by tan 38 and divide by tan 38. These two cancel each other out, just left with the x here. So 184.5 divided by 38 tan equals, and that equals 236.15. How far is she from the castle to the nearest foot? 236 feet. Anybody not get 236? Please remember to subtract how far the person's eyes are off the ground when you're doing angle of elevation problems. If you use the 190, you're going to get a different number for how far away she is. All right, look at page 581. Example number 2 there. I'll read it to you. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person to the nearest foot? All right, so you've got the water down here. Let me make it nice blue water. Right? And then in the water you got a boat. Nice sailboat. And there's people being rescued off this boat by a helicopter that's up above it. Now, your drawings may not be as good as mine, but that's okay. It's a happy helicopter. All right. So they're rescuing people out of this boat. So they're right above the boat. Okay? They're 18 feet above the boat, as a matter of fact. And then they see this old boy over here in the water, and he ain't doing so hot. Okay? He's like, and he's not happy at all. He's like, help, come get me. So look, they're looking down at this guy at an angle of depression. Angle of depression of 42 degrees. So that's your angle of depression. 42 degrees. Okay? And what do they ask for? How far is he from the rescuers? The rescuers are over here in the boat loading these people on that, that hoist. So since the helicopter is vertical of the boat, we've got a 90-degree angle right here. And we're looking for this distance right here from the rescuers to the guy in the water. So we'll make that our variable. Now remember, this horizontal line coming out of the helicopter is parallel to this line. So this line of sight is a transversal. And if that angle is 42 degrees, then this angle down here is 42 degrees. All right, and in relation to this angle, we've got an opposite of 18, and we got an adjacent that we're trying to find. So that's a tangent problem again. So we can do tan 42 equals opposite over adjacent. Looks like the same process. All right, there's your proportion. When you crisscross multiply, we got tan 42x equals 18. And we're going to divide each side by tan 42. So x is going to be equal to 18 divided by 42 tan equals 19.99. They wanted it to the nearest foot, so we're going 20 feet away. The rescuers are 20 feet away from the guy that's not doing so good. Hopefully he's got his life jacket on. Yes, sir?
He's as big as the boat.
He's a big guy. He's a big guy. He's almost as big as the helicopter. Yeah. We'll put down here in the fine print, drawing not to scale. A little asterisk right there.